So the first thing I'm going to do is what you will do in the physics lab. We're going to go down and open up. In fact, here, let me close this and I'll reopen it. So you go down to Logger Pro 3.9, open it up, and then from there, remember that we're going to go right to the experiment that we're using, right? So we'll go right into, I'm going to open recent, I bet I could do, right there, card on a ramp, right? And so it's going to open that. It says CMBL is the file type for this particular application. And there it is, right? So now it's all preset for us to take data. Okay, we had just done some stuff yesterday, so let's kind of go back to where we were yesterday. I need some new assistants for today. How many? I needed 2, right? So who we got for today? Who we got for today?
Ahmad and Nick.
Ahmad and Nick. Okay, that's fine. You got the next one. Okay. So come on up. You guys see if you've got skills.
Yeah, link to get into the.
Say it again.
The link to get into the.
Oh, it's that.
Did you pass your honors chemistry class?
Okay, everybody's in? Okay. All right, here we go. So I need my assistants up here, please.
Yeah.
Assistants?
Yeah.
Okay, Ahmad, you're going to be the catcher. So Nick, you want to do this too? Okay, Nick. So you're going to be the guy that you're just going to do this. You're just going to give it a little impulse like that. You don't need to do that. You just get out of the way.
Okay.
Just in case it's going too fast, then you catch it. Okay. So I trust you to do this, Ahmad.
Yeah.
Okay.
Oh yeah.
So that's all you're doing, right?
Oh yeah.
And then we're going to see if we can see what just come around this side.
Okay, don't throw it lightly, Nick. Don't throw it too fast.
Okay, and so Nick, what you want to do is you want to try to not move around in the background too much. You're just going to kind of give that a little push and then just sit still. Okay, ready? And go. It's got to be a little bigger than that. Let's do it again. Okay, ready? Hang on. Ready? And go. Good. Okay, very good. Okay, oh shoot. Okay, let's try it again. Sorry, you had a great, that was the best one ever, but I screwed it up. Okay, ready, go. Good catch, Ahmad. Okay, start again. Okay, ready, and go. Very nice. Okay, so there's our data, right? This is, now let's make sense of this. We've got 3 graphs. You guys can grab a seat for just a second. So we got 3 graphs here, position versus time. Does that make sense?
Yes.
It does, doesn't it? So it starts off up here at some distance at about a little over a meter away from the sensor, right? And then the position relative to the sensor is going to get smaller as it gets closer to the sensor, and then it goes back up. So that looks reasonable. Okay, what was the problem down here? We had just kind of started talking about this.
Over 50 meters per second.
Yeah, it didn't auto-calibrate very well, did it? Right? I mean, those are really large velocities. We don't need such big velocities. So what can we do? Now, I got to see if I can remember how this all works. So one way you can do this is you go over, and if you right-click on this axis, you can go to, I think it's graph options. Yes. And then we go to axes options. Okay? So look, we've got the y-axis and the x-axis options here, right? So for the y-axis, yeah, the label's great, it's velocity, but what's wrong with the y-axis is the top and the bottom, right? The top is 19.201. What should it probably be? Probably something more like 1, right? I mean, like a meter per second. And we'll see, we can always make it smaller if we need to, but we'd like to spread this out as much as we can. Okay, that's much better, right? Okay, so once again, we just spread out the y-axis, right? Okay, everybody with me? Okay? down here, same thing. The accelerations, it looks like, I mean, those are way too big. So let's, I think you can even, I was going to check that. I think you can even do this. So if I type in like 1, and then I go down here and type in -1, look what it does. Okay, so let's make these maybe a little bit different. Let's make this one like -2. Okay? Make sense? Okay, so talk to me about that stuff a little bit. What's happening there? Okay, so many little fluctuations. There are so many little fluctuations because the data is a little bit noisy. The acceleration probably isn't really changing that dramatically, although it might. It might be changing a little bit because as this thing rolls, there's going to be a little bit of unevenness in the bearings and things, right? Okay, and we'll talk when we get into forces. We'll talk more about that stuff later. The acceleration data, though, that's probably got some kind of a calculation involved in creating that waveform too, and so it's a little bit noisier. But we have some techniques here for getting rid of the noise. Okay, if we wanted to analyze the motion of the cart when it's in free fall or free roll, we should say, right? When it's freely rolling, ignoring the little bit of friction on the cart itself, right? And it's pretty low friction. These are nice carts. What's the only force acting on the cart that's causing it to accelerate? Gravity, right? And now gravity is kind of smeared out here a little bit because it's on an incline, right? And this is what Galileo did when he originally studied gravity. Gravity moves pretty fast. If you drop something in free fall, and you don't have really good equipment like we do now, like in Galileo's time, they had nothing, right? It's pretty hard to study freely falling objects if they're in free fall because you can't time them accurately enough. So what he did is he rolled spheres down planes, and he smeared out the effects of gravity, so he was able to study the acceleration more slowly, right? Which is essentially what we're doing here, right? Okay, so which part do I really want to investigate then? Can you tell me the story that's told here? We push this thing up the ramp a little bit, and then it rolls freely up the ramp. Where should I start investigating this data and why? Somebody tell me, notice all these are lined up vertically. So the time is along this bottom scale. Can somebody tell me when they think that approximately the car is first in free fall?
As soon as it leaves an extent.
Okay, but where is that? What time on the graphs would that be? Say it again.
Half a second.
Half a second. So right about there.
I mean, on the
No,
bottom.
it doesn't even start moving. It's like
So about
0.9.
right there. Is that what you're saying?
Even for that.
Tell me when to stop. Okay, so right there. Okay.
No, because that's accelerating in next hand. That's not when it accelerates.
Okay, yeah, what's this big, let's look at this big dip right here. This is telling us that there is a large negative acceleration. Okay, from the perspective of this guy, what would that be if I'm pushing on this thing? Yeah, okay, the invisible hand is no longer invisible. It's right here, isn't it, right? The invisible hand is now visible, and it's accelerating it towards this thing. So from the perspective of, I guess it would have been almost better to have this thing turned around so it would have lined up with the positive x-axis, right? From my perspective, it is. Actually, yeah, from my perspective, it is. From my perspective, think about from my perspective, that's the positive x direction. And so acceleration going in this direction would be considered negative, right? Does that make sense? Okay. So that really steep dip right there, that's when Nick is pushing on the cart, and it's creating this large negative acceleration. Why doesn't it, let's look at all the intricacies of this. Why is it that it's not just a squared off waveform?
It's not perfect transition.
Because why?
The acceleration
acceleration force will have to cancel itself out before it can fully take effect.
Okay, yeah, did he didn't hit it with a bat, right? He kind of gently pushed it, right? Go ahead, you want to add something to that?
Oh, no.
Right, and so it doesn't immediately, the acceleration just doesn't immediately go from 0 down to negative whatever the maximum was. Everybody see that? It takes a little bit of time. Plus his fingers bend and there's a little bit of an impression on his fingers. They splay out a little bit, right? They flatten a little bit. I mean, so that's all the kind of stuff that's happening there as it gets down to its maximum acceleration. And as he lets go, it's kind of a gradual process too, right? Okay, so I'll re-ask that question again then. Where do you think that this thing first goes into free fall? Free roll?
About 1 second.
About what?
1 second.
About 1 second, so right about there? Okay, be a little more accurate. A little farther? Tell me when to stop.
Right there.
Okay, about there, right? Okay, that makes sense? About that point, what happens to the acceleration? It levels off and it appears to be fairly constant, right? Does that make sense? Think about it compared to what we talked about in class. If I throw a ball up in the air, when it leaves my hand, what are the forces acting on it? Gravity. So what's the acceleration of the ball as soon as it leaves my hand the whole time it's in the air? Negative 9.8. It's a constant acceleration, isn't it? Right? So this should be, because it's on a ramp, it's diluted, but it should also be a constant acceleration, which it is, right? It's not a full 9.8, right? It's quite a bit smaller than that. And why does it show up as positive on here? Well, because on here, gravity's accelerating the car in the positive direction relative to the sensor. Does that make sense? Okay. All right. Okay, so yeah, so we'd want to probably start about here, and where would we want to stop our investigation?
Right there.
Right about in there, right? Okay, so there's some things we can do then. So if we wanted to, for example, calculate what that acceleration is, I could do something like this. I could grab, what I would do is I would make it a little bit shorter. I would be safe, right? Because we've got thousands of samples in there in that one little bit of time. I mean, this thing is taking samples. You can hear it going. Each one of those is a sample, right? So I'll probably just grab it like from there over to there, and I'm going to go up and I want to go to the stat icon up there. If I click statistics, it tells me lots of stuff. Well, what are all those statistics? Make this bigger so you can see it a little bit. Oh, I guess oh, that does the axes, doesn't it? Huh. Interesting. Interesting. So let me see if I can... Oh, never knew that was an option. How about that? You learn something new every day, okay? All right, I guess I can't make that any bigger. Can you guys, you can't see that very well. It says statistics for latest acceleration. Minimum 0.4611 at 3.050 seconds, right? What that means. Maximum 0.7473 at 1.85. And I'm on this interval right here, right? And then it tells me the mean and the median. Now that might be useful, huh? Right? Knowing what the mean is 0.6117, so that's giving me a pretty good estimation. If I average all these data points, I'm averaging out the noise, right? Does that make sense? Okay, so even though there's quite a distribution there around the center, in average, I'm going to get a pretty good value. What is it? It tells me that the change in Y, so the maximum change from min to max is a little less than 0.3, but it tells me the standard deviation. It tells me the standard deviation is 0.078, so it's giving me some idea about, plus or minus how far could I go and still expect that, plus or minus that much is going to be a pretty good estimate. Okay, make sense? So I can take advantage of the technology to give me an average there. Okay, what about talk to me about the velocity time graph. We're going to this first one, we're just kind of going through this. We'll talk about it, and then you can make sense of the lab in your groups based on our discussion. Okay, what can you tell me about the velocity time graph? Looks like it's fairly constant, doesn't it? Right? Remind me what the relationship is between an object's acceleration and the velocity time graph. Slope. Okay, so can you think of another way that I could potentially find an estimate of acceleration here? Okay, if I could find the average slope of this line, does that make sense? Okay, how could I do that? Are you familiar with that? What's the mathematical way that we could come up with an average slope, so to speak?
Integration.
Say it again?
Integration.
Well, that's not really what I'm getting at. I mean, there's a tool, the statistical tool that's built into this that works really well for this. Yes, ma'am. Okay, if I pick 2 points, then I'm at the mercy of whether those points are, there could be some variation, right? Okay, but there is a statistical method for dealing with this called regressional analysis. Have you guys, I do a lot of that in like Algebra 2. But I don't know if you guys have you ever seen regressional analysis before? Not really? Okay, I gotta show this to you. Regressional analysis is huge. So this means that you're gonna take all this data and you're gonna do, technically it's a least squares fit is what it is. But there's an algorithm where you take all these data points and it's going to it's going to create the equation of the best fit line for all those data points. So I'll go down here and I'll pick the same interval. Okay. And on that interval, I'm going to go up here to linear fit. Okay. Click on linear fit, and it tells me all this stuff. It tells me that the best fit line for that region of data on that curve is y equals mt plus b, where the slope is 0.6345 meters per second, and the y-intercept is, who cares? We wanted slope, didn't we? Right? So that's giving us a value. Oh, the other one went away, didn't it? So I want to keep that there. I think now I can come down here. Oh, no, there's the other one right there. Good. So these two accelerations don't exactly agree, but they're fairly close. Right? Using the best fit line method, we end up getting 0.6345, and using the average of the acceleration measurements, we get 0.6117. Fairly close, though. Now, within error, they're fine. The root mean square error is actually they're not quite. They disagree a little bit. Okay. They disagree. The margin of error doesn't overlap on those two. Okay? But they're both pretty accurate. We'll talk later about which one maybe is more accurate. Okay, there's one other method we could do with this. So if I look at the position versus time graph over that same interval, and you guys can do all this stuff I'm going to take another set of data and export it to you guys, and then you can use that data to capture all this stuff on your own, just using the Google app. Okay. What is the shape of that curve right there? It's a parabola, isn't it? Parabola is quadratic, isn't it? Right? That's a quadratic equation. It's the graph of a quadratic function is parabola. So if I take that little bit right there and I want to do a fit, let's see, curve fit. Okay, so I'm going to hit curve fit, and I want it to be quadratic. So that's going to be this one right there, right? ax squared plus bx plus c, only we're using t's instead of x's. Everybody agree? That's standard form for a quadratic function. Okay. And it says right there, quadratic, I guess, done. Okay. Fit type, automatic. Hit try fit. Okay. And it gives me, where did it show up? Oh, right there, I guess, right? Okay, we'll keep that. Okay, what's this telling me? This is telling me that A is equal to 0.3229 plus or minus 0.001560, et cetera, et cetera. How is that related to G? What's the equation that would apply in this situation where we've got accelerated motion, right? We're measuring acceleration as a function of time, right? We've got some kinematics equations that would apply here, right? Which kinematics equation is going to be, which one's the quadratic? Right, don't we have something like, yeah, the third one, right? I've got position, this is a position graph, right? I've got position as a function of time. I'm going to write it that way. Position equals initial position, which is a constant, right? Plus v naught t, initial velocity, a constant, right? Plus 1/2 a t squared. Well, we're trying to calculate acceleration, aren't we? Right? So whatever the coefficient of t squared is, that's equal to 1/2 a. Right? So in our model here, it looks like a is 0.3229. So what does that imply the acceleration is about this? That's equal to 1/2 a. So I would just double it, right? If I double it, that's getting pretty close, once again, to these values, isn't it? Right? Okay, so we're getting slightly different predictions for the acceleration of gravity based on which method we're using. But those are the three methods that you're gonna apply to the data. That make sense? Okay, so let's capture one more set of data, and then you guys save it. And then we'll move on to part 2. Questions on that? I mean, I know you're going to have questions when you're doing this, for sure. That's fine. But you kind of see what we were doing there? Isn't this amazing that you can, I mean, think about that. That's pretty cool that we can capture all those data points and apply these mathematical tools just like that, right? That makes, physics actually works when you have nice tools like this. All right. So volunteers or lab assistants, come on up. We're going to do one more here. Actually, we're going to take several. How many do they want us to take on this lab? We'll go ahead and just gather the data. I can't remember. We'll just follow the rules. On this one, I think we're just taking one. All right. Yeah, we're just doing one for this. I mean, that's fine. Later on, we won't get into that till next lab, where we're going to average results from multiple attempts. Okay, ready? Go. Good. Okay, very nice. All right, so everybody get that? Everybody get a copy of that one? Yep. Okay, go ahead and save that to your folder. Give it a name. Why don't you call it like Lab 1, Analysis 1, Data. Okay, save that in your Google Drive.
All right, we did it.
You should be able to still access it. What's it look like?
Okay, so look at. But like even so.
Oh, that's the older one. Not one analysis.
It might be. I don't know. I connected.
Let's say it is Y.
How do you?
I forgot.
That is the old one. So you should be able to import this one though. I don't really know how to use this very well from your side. Let's figure this out.
Can I click on the
little top
file?
right corner where it's right untitled.
There you go.
Yeah.
Oh, okay.
What's up?
Or you could just,
Just hanging out?
yeah, new experiment, do that.
I think that's
You're
it.
a user.
Yeah, that's bad use time.
So maybe we can open this one.
Okay,
But
right.
that's it.
No email that one.
No, don't
Just
say.
try-
You know my email there.
Oh, I don't think so. I think you want to, I really do think you want to start a new experiment. See
No,
if that does.
no, you wanna go to save as.
But that's saving this one, we don't want.
You not a lot of
This
data.
is the old one.
Yeah.
We don't want to save this one.
Just try this.
What is your group?
This group right
Don't
here.
save.
Cloud King.
I'm not gonna.
Data sharing.
Cloud King.
Same stuff.
It's like,
Cloud King counties. We've got coin ones for.
And,
shared Yeah, yeah.
It's gotta be an easy way to do that, but I bet that'll work.
Lord, change your group. I told you.
There it is.
Lord, went to,
Okay, so save that. And then once you save the data, you should be able to, you guys can tweak the axes, you can do all that stuff. Did you see on here how you can replicate what I did too? There's some tools. Everybody come around here for a second real quick. Like if we do, did you save that?
yeah.
Okay. Everybody come over here. Come over and have a look. So if we do something like this, for example, let's go on here and let's rename.
You're not always just like this.
So, edit graph options. Okay, so the y-axis. So what did we say that one went on? We went from -1 to 1.
yeah.
Negative. So here's just all
you
your
want
data.
Yeah,
Accessibility
the accessibility is on.
But I got you tricked, they look really real.
Oh,
No,
here.
neither.
Hooks out.
It's good to have a Nick around.
Supreme.
Go, Nick. Go, Nick.
How much is?
Automatic keyboard.
I wasn't gonna touch them.
There we go, perfect. So you're gonna go -1
No, they
to
don't.
1.
No, they don't, you already told me.
And then what you do is just hit enter, or just get, okay, so now look what it does. Right, so then we wanted to, for example, get a best fit line on this thing, right? So let's say we're gonna go from there. So we're gonna go from there. What was it? We're gonna go from, there we go, there to there, okay? So we're gonna go from there to there. Now I can go down to graph tools and I can do apply curve fit. Okay, so we're gonna do linear. And I can choose a pull down menu. I can do different ones. So there's my linear fit now. Is that totally? Yeah, it's trying to.
I don't know how I got to the first menu. We got here after that happened.
Why is that not?
So, everything now.
Nick, what's wrong? Fix it. This isn't, how come this isn't so bad? You can't make that.
I think it's a glitch. I agree.
It's because Chromebooks are inferior to computers.
So you're like.
Oh, yeah.
You mean Android?
Well, that's just chart, so, yeah, go ahead there. You have to grab the whole.
Let's get
Oh.
Yes. So you have to do this.
That was a long channel.
Alexa.
Fire OS.
Amazon software. Light first bit. And then, just external.
But it's there.
It's reason why.
Okay, one thing you might have to do is you might have to split this into, like you can do this. We go
Or
up
you
here.
can, wait, it'll let you scroll down.
It does? Oh, okay, it does. All right,
Oh.
so it's all there, okay. So it's all there, all right. Okay. So it gives you your linear fit, it gives you all the information, you just have to scroll within that little box.
It's a very small box.
It is, and I think we'll have to experiment with this a little bit, because this is a different side of the app, I haven't seen this. I think you might be able to go up here and do some things like, yeah, one
Yeah,
graph.
you can do the table as well.
So you can go down, see, this is nice, so then we can go down, and how do I get to the other ones? There's, but I can spread it out. So Nick, how would I get to the other table? I mean, how would I get to the other graphs? I want to know, there's acceleration and everything.
Yeah.
Oh, I got you. That's gonna be cool. See what I'm saying? I want to be like on this graph. And then go up and do this graph. That would take some time.
I don't.
They're called panels.
Tutorials.
Yeah. I know what it
With
is.
my all else fails.
Nobody watches the tutorials.
Nobody does.
Anyway. Well, maybe that's how we do this together. Yeah, I mean, you might have to move like switch places or something. You guys will have to mess with that stuff. You tell me, teach me how to do it.
What?
Okay.
What kind of class is
So,
Here's this faulty graph system.
Yeah.
Figure it out.
Yeah.
Tell me how to use it.
okay, so, well, you'll be able to do this on the computers in the future, right? Okay, so now, everybody's got that stored. Here's part two. Okay, part two, we're going to get some bounces in there. So here's your data for part two. We want it to bounce 3 times, okay? All right, so we need to fix... Let's let the x-axis go from 0 to 10 instead of 0 to 5. Okay, everybody see what I did? And we're gonna do this again. Labbies, come on up. Okay, everybody save that one and then you're gonna go to new experiment. Or actually, just save that one and can you close it or something? Okay. Okay, here we go. Ready?
No, not yet. His strings up.
Oh, okay.
Well, how much does this motion detector cost?
Okay, here we go. Ready?
Wait,
Set. Well, you just let it keep bouncing. It's fine. Go. Oh, how come it stopped at 5?
The measurement is a 10, and
But I just have to go down. Okay, I think I have to go. Jeez. Let's see. What do I want to do here? Data collection. Duration. That would help. Duration, 10 seconds. Okay, sampling rate, 20 samples per second. That's going to be good. That'll be good. Do a jillion. Okay, ready?
You got this, Nick?
Go. Okay. There you go. Pretty good data. We'll take that. Okay, store that one. Call that Lab 1
Analysis 2.
Analysis 2 data. Lab 1 Analysis 2 data.
You got it. Okay, this program really sucks.
It's the Chromebook one. It looks like it is a little less than. Let's just say that. Still pretty cool.
You have to enter the URL like 80 times.
Yeah, there's got to be a way you can avoid that. There's got to be a way you can just.
But you want us to figure it out.
Yeah, I want you to figure it out. Yeah. I'm an old dinosaur. I don't this all this tech stuff. It just doesn't make any sense to me. In my day, we didn't have tech. What did you have? You get it? Did you figure out a way to not have to go to the URL each time to be able to just acquire data without? How did you do that? Like, so there's the new data. Did you have to go log into the website again to get that?
I actually, well, I did. I remember. Yeah.
I wonder if there's a way not to have to do that. That's what I'd like to know. If you can just, like refresh.
I think I did. Sorry, what you do in your age?
Why don't you guys watch the tutorial? Dan, tell me that.
Right now?
No, not right now.
Joe, what did you do in your age? Like, what did you do when you were in high school?
What did I do?
Yeah, when you were learning that stuff.
What time, when are we out of here?
4 minutes.
4 minutes, okay.
Sure.